My name is Shadi Albarqouni. I'm professor of computational medical imaging research at the University of Bonn and the University Hospital Bonn. I'm also young investigator group leader at the Helmholtz AI in Helmholtz, Munich, Germany. And we indeed focus our research themes into three areas. So the first one is computational medical imaging. What I mean with that, we do basically work with medical imaging, no matter the modalities, no matter the disease, and try to build computational algorithms. Nowadays, with the AI deep learning algorithms, to make the life of our physicians, radiologists much easier, and hopefully with better, accurate, fast algorithms that make their life easier. So this is one research theme, but we also realize over time that we also need to work on these data that are distributed among different hospitals, work with annotation efficient algorithms. So that means with zero, like almost no annotation. So we don't want to ask our beloved radiologists to work so much work, hard work. And this is where comes the second theme, the federated learning, how we could train algorithms in a distributed fashion, in a privacy preserved fashion as well. So we want to also protect the privacy of the patient's data, etc. So this is the second theme that we are working on. And the third one, which is indeed the closest to my heart, but we don't have so much progress there, is the affordable deep learning or affordable AI. How we could make these algorithms that we develop affordable, meaning this could go multiple directions. But you could think about it, or different axes could be, one of them is the machines, the devices itself should be affordable. That could be in anywhere. But we are focusing more on computational algorithms to make it really affordable, that could work on low resource settings. So this is what I mean by affordable AI. And we are getting into this, not so much work, but this is something really I'm highly interested in. Think about also developing these algorithms and deploying them in low resource settings like low middle income countries, etc., or remote village, even in developed countries. I mean, the reason is we have progress or developed so many works on federated learning that some of them get attention, the others no. And this is the reason that I would love really to talk to you about, maybe we get also more attention. So as I said, the research themes that we are working on, the computational algorithms, and this is learn to recognize limited amount of data, learn to adapt, there's training, testing, distribution coming from different domains, different scanners, different demographies. So this is where domain adaptation, etc. There's also another work that you could make it that let the model generalize to unseen classes or unseen domain. This is something that we have worked on. How you could model non-imaging data, right? Not only imaging, like electronic health records. So this is with geometric deep learning. This is something that we have worked on. A few years ago, we worked also on reason and explain, to make the models more interpretable, or trustworthy. This is something that we have worked on with a couple of colleagues from Stanford or ETH Zurich. But what I recently was focusing on is federated learning, how we can train models in a distributed fashion, preserving the privacy of the patients, and developing more powerful algorithms that work with this data. So one of the recent works that we have just published last year at the Nature Machine Intelligence with impact factor of 25 something, indeed, is this work. So what we are doing here, basically, we thought, what about training an algorithm to detect lesions or tumors, not only detecting them, but segmenting them, annotate, find the lesions, right? Quantify them with simply zero annotations. So we have asked our radiologists with zero annotation to, with zero efforts, basically. So the basic idea is to train the algorithm, which is simply simple autoencoders, to understand how the healthy brain look like. And I mean, to be specific here, we're talking about MR brain imaging. And so we trained the algorithm from distributed data like different publicly available data set, as you can see here. I don't know if I can maybe highlight some stuff here just to make your life easier. So these are different hospitals with only healthy data. So we trained the algorithm to understand the characteristics of healthy patients. Okay, so why we need to do so? Well, once you provide the model with these patients which has unhealthy or lesions like multiple sclerosis or glioblastoma, then the model what does try to produce a pseudo-healthy version of that patient. Pseudo-healthy, like just simply without tumors. Well, then, if you do the subtraction of this guy from this one, you basically would get the lesions. And this is where you could quantify, you could also do whatever, all the metrics to see how aggressive that lesion is or the tumor is. So we trained the algorithm on these different hospitals, and we do test it on 6 hospitals here. So the training, I think, was on 1,500, like 1,500 patients. We tested on around 500 patients with multiple pathologies like multiple sclerosis, glioblastoma, etc. One of the challenge, though, that whenever you train this algorithm on this healthy coming from different hospitals, it's well-known problem in the MR modality, in the magnetic resonance imaging, that due to the characteristics of the magnets, different devices, etc., that the images would look differently, even the same patient, if that goes from one scanner to another, Philips, Siemens, etc. So we thought about, we really need to have something novel, how to disentangle the representation into 2 representations, something we call it shape, which is indeed encapsulate or represent the shape of the brain, and another one encapsulate or encode the appearance, how the brain imaging look like. And this is how, we try to make it easier for the model to train from different hospitals with different characteristics. So basically, we only share the shape parameters because this is common among different hospitals. The brain shape wouldn't change, but the appearance, we keep it locally into these different clients. And this is how we made the training, and we indeed just got pretty cool results and performance from this model. So what we basically were doing, we contributed with this Flumpy framework. It's really, we did benchmarking this framework on multiple databases, multiple medical databases, to see how that works compared also to the state of the art, right? So we basically paved the way to our researchers, our young talents, to whoever like interested in federated learning, to develop their work and just easily benchmark it with our framework. Yeah. So this is an open source code that everyone could access it. The experiments, the setup, etc. It's also there. So you could easily just plug and play and just your own algorithm and compare to the state of the art algorithms, basically. Also, the leader of this project, who are from Auken, I did work with them on a couple of occasions, etc. So this is where we met in the past, and we even submit some joint works together, proposals. Then we came together to this publication. By the way, Auken is one of the pioneers in federated learning. Indeed, this is a very good question. I very much like it. I have been working on this developing AI with medical imaging since a couple of years, maybe 8 years, probably. And honestly speaking, we do work on there's limited amount of data here and there and over there. And we have some progress here and there. However, I truly believe we should have this collective intelligence. Yeah. And I do believe in this statement. To address your question, Ralph, I do believe in collective intelligence. And indeed, there is a pretty cool book that I read a few years ago. It's called The Wisdom of Crowds, that you see it here on the screen, from James Servitsky. The main message that he was telling there that crowds are smarter than individual, no matter how brilliant they are. Yeah. But the cool thing, he set few conditions to make this happen, right? This collective intelligence. So one thing, oh, it's not there, but I could just recall the conditions: independence, diversity. It has to be also, there's tacit knowledge that you really need to know about it, and also coordination and aggregation. And just think about it, reflected to our clinical institute. We have so many clinicians here and there, coming with different schools, different diverse backgrounds, right? If we need to integrate all this knowledge, aggregate it and coordinate it to really produce more powerful AI algorithms, yeah? Rather than just training from individuals here and there and over there, yeah? That make it so special and close to my heart, please. And then let me just move on to another work that we published with another student. His name is Tariq Dare. He's from Jordan, by the way. And what we did here, we tried to train, so this is another federated learning work, yeah? But we call it like semi-supervised peer learning for skill aging classification. Oh, the basic idea here, what about training an algorithm, a deep learning model to do skill aging classification, but presumably that those data are distributed in different sites. However, the main assumption here that there are some clients that they have zero annotation. They haven't made the efforts to do the diagnosis. Some others, they have partially. Others, they are really into it and they have done so much annotation, diagnostic, etc. So we were just thinking how we could work with this kind of, let's say, the data that naturally there in our hospitals, yeah, or kind of noisy annotation even. So this is where indeed we were targeting this work. But what we try to do, try to have this kind of peer learning. So imagine that there is a student that he is not great in doing the task. So let's have a peer learning, like kind of peer coaching. So we match him with another student and try to learn together something, right? This is what we basically did here. Try to see if there are two similar institutes that they share some sort of characteristics, maybe the data, maybe the weight of the model's distribution. Then let's bring them together. Maybe there is a match, and then let's learn from that match. So maybe they spark something, and they really would do something awesome, right? So this is what we did. And we found out this really brings us pretty cool results in terms of numbers, in terms of F score, precision. You see here, the numbers are much better than state-of-the-art semi-supervised learning, and much better than the local models, yeah? And to some extent, it's even better than the upper bound model, right? So here you see the numbers, how great they are. Another interesting project that I do have with our partners at TUM LMU for radiotherapy, etc. And this is, I need to highlight it because I'm looking forward to hiring two positions, Ralph, one postdoc and one PhD. I would be more than happy to get these positions from your side, from your readers, Ralph.
I would be happy too.
Yeah, great. Oh, there are a few things that I would like to highlight, not this slide. I think there's another slide. Yes. Our lab is also quite active into our community service. So I served like as a co-chair in middle last year in Switzerland, India also last year. We organized a couple of workshops like FAIR, like this is affordable AI in healthcare, distributed and collaborative federated learning. We also proposing this for the next year, the fourth version of this DCAF workshop. I'm area chair at the MICAI, and next year I'll be also organizing committee for the MICAI 24. But apart from the community service, Ralph, I'm also a steering committee member of the Arab German Young Academy. This is really cool because I'm able to bring some interesting projects to our young talents. So this is one of the interesting projects that I brought to Palestine, to Gaza Strip and West Bank, where we organized this job market skill in Palestine. We were able also to organize it in Egypt, and we're going to do it in Libya, or we had it last year in Libya. We would have it in Lebanon next year. We organize and also awareness campaign in Tunisia, like on antibiotic resistance. We organize a bioinformatics workshop in Tunisia. So many applicants from like the MENA region, basically. As I said, like I'm also quite active. There's something in Jordan, King Hussein Center for Cancer. We were trying to collaborate with them and basically was trying to do so. Also trying to disseminate the Arab Germany Academy also in the Emirates. In Dubai, this is like the Mohammed bin Zayed University of AI. We're trying really to also advocate and support also the young talents,